Hi everyone. I'm so happy, so excited to join Antonio and Manuel on this talk today, celebrating the International Project Management Day. So when Antonio a couple of days ago said to me, Ricardo, we need to do something to celebrate the International Project Management Day, and I said, oh God. And then he is in Madrid flying tomorrow. I am in Iceland, but then we said, let's do one thing. And then I told him that I watched Manuel's talk um, maybe 4 weeks ago. I watched it on YouTube in Portuguese. And I said, look, project managers need to know that. Okay. They need to understand that what is happening with AI, it's not something that it started yesterday and then suddenly dominate everything. So it's a much more deep process. And Manuel explained this in an amazing, truly amazing way. So this was the way Antonio and I found to, I would say, to celebrate this day. And Manuel, first of all, thank you very much for your time, and for accepting. So just to tell you, Manuel is a great friend. We know each other since 2010. We were
Yeah.
colleagues at MIT,
Yeah.
and we became very good friends since then. And he does not want to be recognized as that, but he's my sounding board in terms of tech. So every time that I am struggling to understand, what is going on Earth in terms of technology, he is the one that I talk, and he is the one that gives me insight. He is absolutely brilliant. He is a venture capitalist, and he knows extremely well from inside out what is happening. And he moved 2 months ago, right? Two or 3 months
Three,
ago,
three, 3 months. 3 months.
3 months ago,
Yeah.
to the Silicon Valley to go and to stay closer to what is happening in AI. So before I turn into you, maybe Antonio want to say a couple of words before we jump into the
Yeah,
meat,
no
the
more.
subject here.
Ricardo, first, Manuel, thank you for being there. I didn't want to watch the YouTube video because I knew you were coming, so I want to see it live. But
Nice.
no, thank you. Really short notice, like you said, Ricardo. We decided to do something like 4 days ago, 5. But this is how AI works, and we have
Yeah.
embedded this philosophy in everything we do with AI. We need to move fast. We might not do it perfect as we are used to, but that's not
Yeah.
the point. We just need to move forward. So thank you, Manuel. Thank you, Ricardo, for organizing, and thank you, everyone. More than 100 people plus many others online to joining us today. So that's
Yeah.
all. Thank you. Looking
Yeah,
forward.
Manuel. So I will leave the floor to you.
Mhm.
Okay, Antonio, and I will leave the floor to you. And now the ball is you. Remember, try to give us as many insights as
Oh,
you can. Okay, to
okay.
help us to
I'll,
navigate that. Okay, thank you.
okay. I'll try to survive the expectation and the kind words of Ricardo and Antonio here. Let me share my screen here. Let me see if it's please tell me if it's working. Is it there?
We can see it. Yes.
I'll try to put the overlay here, and I think it's gonna be. Is it is it good, Ricardo? I don't know exactly what you guys are seeing. Okay, so everyone, it's a big pleasure and a big honor to join Ricardo and Antonio here in this important day, International Project Management Day. It's we know the importance of this discipline and these type of skills on building the world that we live today. Um, and I'm very happy to be here talking about the subject that is actually uh, taking care of my mind recently. A few years ago, when I saw the latest developments on AI, I got really interested on what was going to be the impact of that and in how we do everything in our lives. And then I decided to study it more, and to study it more and get closer to the action. So there was this family plan to move to Silicon Valley a few months ago, so that I could exposure my family to what was happening, and I could get closer to the AI ecosystem here in Silicon Valley. So the idea here is to try to situate ourselves on what is happening, because it's a overload of information. It's a development that is happening in a super fast pace. It's very hard to keep up with everything that is happening in the world of AI today. But I'll try to give you a perspective on how those things evolved, so that we arrived where we are today, what we can expect to the future, and a few ideas on how we can position ourselves and embrace this wave of technology in our lives. So to start with that, just a little bit about myself. I really have a hard time talking about myself here, create a chart to make it help me. But I'm a computer engineer. I started coding at very early days when I was around 8, 9 years old. I started coding in my hometown in Brazil, in Minas Gerais, in Araguari. I know there are some people from Minas Gerais here, so they're gonna know the name of the city. But around that time, it was my first contact with computers. Then I decided to do computer engineering when I was going to college. I joined the Unicamp, which was one of the best computer engineering schools in Brazil in '93. And I was very lucky, because in 1993, it was the year that the web surfaced. The internet existed already, but the web, the first browser, appeared in 1993, Mosaic, the first browser. And I saw that at first hand, because the university was connected to the internet. All of our machines were basically hot IP, hot machines on the web. So the idea of the web captured my mind in a very fast way. I said, hey, this is gonna change the world. And I decided to start studying more about that. So I was doing a kind of a dual track in my academic life. Officially, I was doing research in high performance computing and supercomputing, which was basically how to create large computers to solve problems that were too hard to solve with regular machines. But on my B side, I was creating websites and learning about internet and web technology for fun and for my personal development. I started a lot of research on high performance computing. Later, I joined the master's degree at the same university, but I quit the master's later. And in 1997, just after I graduated, I moved to Silicon Valley for the first time. It was my first trip to outside of Brazil. And I came to San Francisco. It was the end of 1997. I spent a few months here in Mountain View, actually, which is the heart of Silicon Valley. And it was very fun, because I was here pursuing supercomputer manufacturers. I was not here for entrepreneurship, not here for startups or for business. I was more of the geek guy. And then I noticed that there was something happening here that I couldn't quite understand. When I got back to Brazil, I ended up founding my first startup. So that was when my route started to move from academia and more to market and entrepreneurship. And I ended up launching my first company. I bankrupted that company. That was around 2000, just before the bubble, the dot-com bubble burst. I joined a big payments company, American company, a listed company in the US, but I was taking care of their operations in technology in Brazil. So that was how I was slowly getting out of the academia and getting more connected to innovation and business. I launched a few other startups. I sold the last one to the second largest media group in Brazil around 2008. And that was a Web 2.0 company. So the interesting of this trajectory and why it's important it here, because it connects to the story that we're going to see on AI. So I saw a few of those big changes in technology and also the evolution of user interfaces and the availability of compute power. So that's part of the whole story. After selling that company to the Media Group, I spent a few more years there as an executive. Started doing angel investments in technology companies in Brazil. Joined a venture capital fund in 2012, Red Point Ventures, which was the first venture capital fund in Brazil that started with a partnership with venture capital funds from Silicon Valley. And on the past 3 years, I was helping Itaú, which is the largest private bank in Brazil, to design a corporate venture capital operation for them. And more recently, 3 months ago, I moved to Silicon Valley to kind of update my software. I just turned 50 last week, and I felt the need to prepare for what's going to be the big wave of a transformation that we're going to see powered by technology with AI in the core of that we're going to see from now on. So that's a bit of the story. I love to study. I met Ricardo at MIT, but I have been doing things at Stanford, Berkeley, Harvard. I think the more I learn, the more I know that I need to study more. You know, it's been always hard to keep up with everything that is happening. So the fun thing is, from first time here in Silicon Valley 27 years ago because of high performance computing, now I'm back here because of AI. So let's talk about the latest news in AI. Now this is just a joke, guys. It's impossible to keep up with the latest news in AI. Everything is happening at a super fast pace. This presentation I prepared actually 1 month before I moved to Silicon Valley, and a lot of the news that I put here are already outdated because there was new generation of technology, of models, on things emerging on the space. So let's abstract this amount of news for a while, and let's do a trip in time to understand where we are with this thing called artificial intelligence. To understand that, I think the first important thing to have in mind, it's not a new thing. Artificial intelligence is part of the computer science discipline since the early days of computers. So the first ideas of creating neural networks that could somehow work as the brain of a human or of an animal was actually just after we created the first computer. So around the 40s and 50 years, we were already talking about neural networks. It was very rudimentary neural networks because that was what the available computing capabilities allowed us to do. But the ideas is from 80 years ago. So if you look into this chart, you're going to see 2 axes on that chart. That chart plots very important milestones and developments that happened in the artificial intelligence over these 80 years. But on the y-axis, you have the costs in compute power necessary to train the algorithms and the models that they were using at the time. So basically what you're seeing is how much compute power you needed to train a model, the state-of-art model at that time. And that's a logarithmic scale. And on the other axis, we have the year, right? So we started with 1940, and then we're gonna see how that thing evolved. So just to put some milestones here, around 1957, they created this first computer that was implementing a very simple neural network using the perceptron technology, the perceptron architecture, which was a very simple one-layer neural network that could simulate, that could process a few, how can I say, functions. The idea of these small neural networks at that time was just to try to identify very simple patterns. For example, in this picture here, you see the computer behind the man, and a camera on the floor plan here, and a C ladder. So that they were trying to create an algorithm that could identify a character. So that's the origins of optical character recognition. So that's and that was the type of problems that they were trying to solve at that time with such a big machine. And just to give an idea, so that we could understand the scale here, to train the perceptron machine in 1957, the training compute power necessary to do that was around 1 megaflop. What is 1 megaflop? 1 mega is 1 million floating point operation. So it means that to train that model, you needed to execute 1 million of multiplication of numbers, just to simplify that in a way. And that was the state of art at that time. Let's move 30 years from that point. From 30 years later, we saw the kind of a new development in the neural network discipline, that they found a way to train neural networks in a way that they could solve more complex problems. And that's what they call it the backpropagation of error methodology. It was a way that you have a neural network, you put that to solve a problem, and if it doesn't solve the problem well, you take the error in the end of this calculation and propagates that error back and try to minimize the error at each cycle of training of the neural network. In the end, you're going to have a very good approximation on the result that you were expecting. To do that, the state-of-art models at the time and algorithms, they were trained using 1 gigaflops. That means 1,000 more calculations than the previous technology from 30 years before. What happened 30 years after the perceptron? 30 years after the perceptron, we arrive in 2017. And the important thing to note here is that we moved from 1 megaflop, 30 years later, 1 gigaflop, that's 1,000 x, now 1,000 more compute power. But now on the next 30 years, we moved from 1 gigaflop to 1 zettaflop. That's 1 trillion times more compute power to train the models. So it's a one, that means the available compute power to train those models grew exponentially because of everything that we already know about the evolution of computers, the evolution of networks, the very famous Moore's law, right? That we listened about that a lot. I'll tell you a little bit more about Moore's law later. But the interesting thing here is this algorithm that appeared in 2017, which is called the transformer architecture. It's actually the origins of everything that we're seeing in terms of large language model technology. So this is the breakthrough, the technological breakthrough that allowed us to create things like ChatGPT. So everything that we're seeing now, ChatGPT, Gemini, Claude, they're based on this idea of the transformers network, which is a new type of a neural network that could be scalable in a very large ways. And the idea here is that the more you can scale a network, the more complex the problem the network can solve. So for example, when we saw ChatGPT generating the first, how can I say, texts that makes a lot of sense, 10, 12, 10, 15, 30 years before that, it was impossible because we didn't have neither the technology available, the compute power for that, neither the algorithms that could allow us to do that. But today we can do that. And then moving a little bit further, if we go to the launch of a GPT 3.5 and ChatGPT that happened in November 22, and that's just 2 years from now, which is crazy, right? We saw another massive change in the speed of the models. And the latest, this is not the latest because OpenAI already launched a new model, but that was the model that they launched in May this year. We had another 10,000 more capability, more compute power on top of the previous model, and that's in a very short period of time. So the important thing to note here is the acceleration of the size of the machines, the amount of computer power that we can put to create those models is getting bigger, bigger, and faster and faster. And because of that, the category of problems that we're solving, they're going to be different. Problems that are not solvable today, few years from now, they're going to be trivially solved. So one good way to see like that is if you walk in San Francisco today, you're going to see a lot of self-driving cars in the road. It's this company called Waymo. You can order, you can hail one of those cars to make a trip from your hotel to your next meeting, and the car is going to arrive there with no driver at all. And that's happening because of this type of evolution. So these type of problems that a few years ago were impossible to imagine that they're going to be solved, now they are being solved. They are on the streets and they can be used and invoked from your mobile phone. So that's where we are today. We are in that point. We just saw the emergence of these new technology called the large language models that they're creating these very interesting applications like chatbot, summarization of text, research, and a lot of ideas. We're going to see, and we already seeing the development of a lot of applications of that on project management. We have been discussing that for a while. So this is just the beginning of that story, because you can extrapolate that curve over the next years, and we're going to see way more development from here. One important thing here is to understand the impact of that. Let's go back to around 2000, and let's make a dive here in this new chart. What this chart shows, each of these curves, they represent the comparison of how good a computer could solve a problem that is trivially solved by humans using standardized tests, and how well the computer is being graded on that task. So 0 is the performance of a human. That means that's what we expect a human to do. And on what the curve shows is how the computer is doing to solve that problem. So from 1998 to around 2015, 14, we saw a lot of those tasks, including comprehension of a reading, image recognition, language understanding, handwriting recognition, computers getting better and better, enriching and now surpassing the quality and the level of a quality that a human can execute those tasks. And that's really important, because before that, I mean, let's say before 2010, we had that idea that computers will only be used to solve very repetitive, mechanical, and not more, how can I say, cognitive tasks. But those tasks here, they're all very cognitive tasks. Understanding a text, recognizing, understanding a conversation. And now computers are being able to do that. And that changes a lot the type of applications that we're going to see for AI from now on. Okay, so far what we have seen is, okay, this is not a new thing. It started 8 decades ago. It has been developing at a very fast pace and accelerating the speed of development. It's going to change everything, because the kind of problems that those computers are being able to solve are problems that right now we're only using humans to solve them, and that's going to have impact on how we understand the utilization of computers for those tasks. So how do we navigate that space, right? So I have a few things here that I believe we need to have in mind when we face this, instead of getting paralyzed or panicking because, oh, this is too crazy, this is frightening because it's changing at a fast pace. How should we look and understand that and bring that to our lives? I think the first thing to have in mind is that this evolution is happening at a very fast pace, and it's accelerating. It's not slowing down. Maybe we're going to see like a slowdown of the evolution of technology, but what we have seen in the evolution of computers and things like that is every time one technology starts to slow down, there is another technology or another breakthrough that continues the evolution of that. So there are breakthroughs happening. So one thing is to support this idea, a few things are important to note. The computers, the type of computers that we're using to train and execute these models of artificial intelligence, they're not using your regular processor, the regular processor that you have in your computer. So when you have your notebook with Intel CPU inside of there, that's a CPU, and that's really good for a certain type of computation. But over the time, people start to use the GPUs, which were the processors used for graphics processing. The origins of the GPU was actually for video games and games in computers, so that we could execute the calculations necessary to render, to design, to make the calculations to plot the images of these computer graphics in your screen. They noted that these architecture of chips were very useful for the type of calculations that we need now for AI. So they're being optimized to do that, and they can do that much better than a standard CPU. I don't know if you remember, but a few years ago, these GPUs were being used to mine cryptocurrencies because they were really good to do the calculations to do that you need to mine Bitcoin, something like that. Now they're being used for AI. They have specific architecture, specific capabilities, especially on multiplication of matrices and things like that. That makes the resolution of the mathematical calculations that we need for AI way faster, and that's accelerating. And that's accelerating faster than we saw with the evolution of CPUs, which was the typical processor of a computer. The models are getting huge. And when I say the models is, for example, when we talk about what is GPT-2, what is GPT-3, those are what people are calling large language models, which is basically a very large neural network that was trained in a huge volumes of data, mostly text. Now they're doing that with multimodality, with videos and images and everything. But to simplify, they are trained in a huge amount of text data to answer questions from the users. And what we learned over the past few years is that's not something that is 10 years in development. That's just a few years. We learned that when you have a network of a certain size and you train that with a volume of data, at some point in time, it doesn't matter if you make the amount of data much bigger, the quality of the answer of the network is not gonna improve. It's gonna start to plateau. But if you make the model bigger, you can now put more data and get better results. That's why everybody's putting a lot of effort in creating more compute capabilities, because with more compute capabilities, we're going to be able to create bigger networks. With bigger networks, we're going to be able to ingest more training data. And with that, we're going to solve problems that were not solved with the previous generation. So models are getting bigger. They're basically doubling in time every 6 months. So when you put that in a long period of time, it's a super fast-growing exponential curve. And the other important thing is that the adoption of those technologies, they're being super fast. ChatGPT reached 1 million of 100 million of users very fast in just a few days. In just 2 months, they reached 100 million of users. For Netflix to reach 100 million of users, it took years. For Instagram to reach 100 million of users, it took a few years, 2.5 years. ChatGPT reached 100 million of users in 2 months. Why that's happening? That's maybe the easiest answer for this whole thing. The main reason is that these technologies are being deployed for the users using existing infrastructure that we spent 3 decades building for the internet. So when you use ChatGPT in your mobile phone, all you need to do to use ChatGPT in your mobile phone is to download the ChatGPT app. There is no installation. You don't need the new hardware. You don't need the new technology. You're just going to use that over the internet. So everybody is just one click away from being able to use those technologies. And the other reason is because it's based on language, the way you use these new large language models is actually talking to the model using natural language. The barriers to use are very low. You don't need to learn about computing, let's say, language to program computer. You don't need to learn how to use a sophisticated software. The learning curve is really, really small. So my daughter of 11 years old, sometimes I see her using ChatGPT to help her on how to solve certain problems that she's trying to solve. And there is no barrier for that. So that's really important. And how do we face that? You have to be flexible. That's the most important thing here. You have to be flexible in how you're going to adopt those technologies in your daily life. You have to assume that that's going to change. So maybe you're using one technology, one product today. In 6 months from now, there's going to be a new generation trying to solve the same problem in a much better way. You have to be able to very fastly change for the new product. Otherwise, you're going to stay behind. And you have to be prepared for a lot of change over time. That thing is far from being a stable ground for the development. The second important thing here is I imagine that on the audience here, we have people from many different areas and markets, right? And you have to understand that it doesn't matter where you are working and where you are living today. Somehow AI is going to touch the market that you are. I believe that all industries are going to be touched by the evolution of AI. And this is very important to be aware, because otherwise you believe that, oh, that's never going to reach my market because I'm super regulated, or I'm a niche, or I'm how can I say, too complex stuff. I'm too close to the atoms and not for the bit and not to the bits. But the reality is AI is going to reach there and is going to touch everything. So in my view, the applications of AI will happen and will transform practically all industries. And the big change here is that we are seeing more and more cognitive tasks being touched by AI before, different from what we believed before. So in this chart here, that's very interesting to see. This is one of the famous research that people did to try to understand what was the exposure of each type of industry or category of jobs. What's their exposure to AI? The way they calculated these exposure is that they use a list. There is a standardized list here in the US that for each job description, for each role that you can have in any industry, they describe what are the tasks involved in executing that role. So for example, let's say that you are an executive assistant. An executive assistant, there's a lot of tasks that she has to execute her function. She has to schedule meetings, she has to read emails, she has to reply emails, she has to summarize reports and things like that. And then once they have these breakup of tasks, they talk to a panel of specialists to understand how much of each of those tasks could be executed by AI. And then they calculated or could be exposure to the AI impact. And then they calculated what was going to be the average and expected impact of AI in each of the professions. And interesting enough is they say that more than 50% of the work is gonna be impacted by AI, assuming the current status, and we don't know what's gonna happen from now on. So we need to expect these things to be more. But the important point here is, don't assume that this means that it's gonna be substitution of the people that are doing that work. Sometimes the exposure to AI can represent substitution, especially if it's very let's say, tasks that the AI can do really good. But in other case, it's going to be not necessarily substitution. It's going to be improvement of what you're doing. So, for example, let's say that you are a research analyst. There is a limit of how much research you can do in a small period of time for a specific project. But if you're using AI now, it's not that AI is going to purely replace what you're doing, but now you can research 10x more content. You can increase the breadth of your research in a big way. You can do other types of tasks. So we have to understand that exposure to AI not necessarily means substitution. I believe that we're going to see a lot of substitution on the way, but that's not the unique way for things to happen. And the other important thing that sometimes is ignored by majority of these studies, there's another study from MIT that they try to put things in with an economic perspective here, which is not just the exposure of AI, but is the feasibility of using AI on that application. So for that, you need to understand what's going to be the economic return on investment for that application. So the fact that a task is could be executed by AI doesn't mean that it will work for you to do that with AI, because there are costs involved in AI. And sometimes the costs of doing that on the traditional way are better. They have better return on investment than using AI. So we need to put that in perspective as well, because AI costs some money, especially if you're doing more sophisticated stuff. It costs a lot of investment. So those are two other things to understand. Everything is going to be impacted. AI exposure doesn't necessarily mean substitution, and you have to understand the economical feasibility of applying AI to a specific problem. The other interesting thing, and that's a part of what I was doing over the past years as a venture capitalist, is that there is a lot of money being invested in AI to find who are going to be the next big tech companies of the AI world. Who is going to be the Googles, the Apples, the Metas of the AI world? We have already, for example, NVIDIA, that suddenly NVIDIA became one of the most valuable companies in the world because of the AI rush. But the reality is a lot of the money from venture capital is being dedicated to create those AI companies. So in those charts here, the first one, we have a graph that shows the amount of venture capital dollar that were invested per year over the past years. And you see that from 2021, just after COVID, we had a boom in the investment in technology, mostly driven because of the remote life that we learned to do. I mean, after COVID, we saw that a lot of things could be done remotely through technology. And but then things started to slow down. It's true that it slowed down, especially in 2023. It's catching up now in 2024. But more important, when you drill down in where the money is being invested now, you'll see that a big chunk of the money, for example, in the second chart, the last bar was all the venture capital investment until May this year, which is close to $45 billion. And almost half of that was in AI companies. So a lot of money is being put there in this first stage, mostly on creating the infrastructure, the foundational models, and the tools. But we're going to start to see from now on an explosion of applications being created on top of AI, because the technology starts to get mature enough for you to use it in a real life application. So if you we drill down where the money go, it went for generative AI model maker, AI drug discovery, Gen AI applications, and we're going to see more and more that happening. And not just venture capital is investing in AI. This other chart shows how much money global corporations are investing in artificial intelligence. And if you take 2021, 2022, we're talking about $400 billion being invested in AI. So that means, imagine how much people, how much brain power, how much research, how much tests are being happening on that. And that just started to happen. So we can expect more acceleration, more innovation, and more breakthroughs happening from here. And this is a chart that I believe we're going to have a hard time to understand what's here, but that's not the idea. The idea here is to show you that it's a very unstable terrain because we're still creating the technology. So everything is being constructed right now for this AI world, from the infrastructure to the application. And when I say from the infrastructure to application, if you imagine that we spent maybe the last 2 decades optimizing how we create data centers, for example, to host the cloud, right? Everybody uses the cloud today on your Google Drive, your Dropbox, your iCloud, your Gmail, everything is on the cloud. We have to find the best way and the optimal way to create these very large data centers for the cloud. But now we're going to have to create the same thing for a new type of data centers that are the data centers designed specifically to handle the workload of AI, which is very different. I mean, when you're handling a Gmail workload, is completely different than training a very large language model in a data center that is going to cost maybe a few $1 billion to train one model. So we're going to have to create everything from the beginning. How is going to happen the communication between those machines, how the networking is going to happen, how we're going to optimize the use of energy. So everything is being created right now. In this first chart here, we have kind of a landscape of the landscape of the artificial intelligence space. Each of these blocks is a specific area in the AI stack that we need to create. And each logo is a company trying to create that solution. And in the other chart in the center, we see the evolution of the evolutionary model of the algorithms and large language models. So you see that there is a lot of things happening. You have people that follow this path of the GPTs, then you have the ones from BART, then you have others. And that's just the beginning. We're going to see that tree to explode, have a lot of branches. Majority of them are going to be not good ideas, but some of them are going to survive, and it's going to be the typical evolution we saw in technology before. And on the right here, maybe it's hard to read, but I did a search on GitHub. GitHub is one of the largest repositories of computer code on the internet, where a lot of the open source projects are hosted. People create something, they put there and they share that with the world. Also, corporations use that for their own, how can I say, to manage their own source code for the programs that they're creating. But I did a searching repositories of code with AI in the description, and I had 1.3 million repositories of code as a response. That means that there are at minimum 1.3 million projects based on AI available on GitHub for developers around the world to use or to learn with that. If I go for LLMs, that's going to be close to 62,000. If I go for AI agents, which is a new thing, 4,500. And those numbers, I believe that if I make that search today, is going to be way bigger, because these figures from 3 months ago, maybe more, 4 months ago. So everything is being constructed. Be prepared that when you're adopting those technologies, don't make a a super strong commitment with your vendor, with the technology that you're using, because things can change very fastly, and you need to be flexible to adapt to those changes. And this is something that I like very much, which is maybe we are on the corner of seeing a massive and a radical change in the way we use computers and systems, a new UX paradigm. For example, I have a few of the latest changes here. In the early 70s and 80s, we saw the emergence of personal computing with Apple, IBM PC, and things like that were very basic type of UX that we had at the time, mostly a terminal and your keyboard, not even a graphical interface. On the next decade, we saw the emergence of the graphical interface that dominates how we use computers today. That was the emergence of Mac OS, of Windows. There was a lot of things that happened there. Later, in the mid-90s, when I got into the university, we saw the web emerging. So we started to interact through the browser, and then we saw the arrival of the iPhone that created this mobileware. So every time that happened, it completely changed how we use computers. It massified how much more people could use computers, because to use computers in the 70s, it was very hard. I remember when I got my first computer when I was in Araguari, it was a very small computer. I hooked that computer to a TV, and when I turned it on, all I had was a blank screen with a prompt. If you want to do anything, you had to write your own code. There was no other way to use the computer. So it was very technical. Just a few people were doing that. Today, with your iPhone, you download ChatGPT, and you're using one of the most sophisticated pieces of technology that we ever created. So that's a big change. And maybe now we're going to see a very, very big change in how we use computers. That's going to be based on a natural language, vision, voice, sensors, context. And one thing that people are talking a lot is agents. Because so far, let's just make a small conversation here about agents. Today, you are moving from, okay, I need to program a computer to have a specific result that I want, or I have to use a specific software. Now I can just ask a chat bot what I want. For example, you upload a list of names or an Excel file to ChatGPT, and you can make questions about that content without having to do the calculation and everything there. So that's a change in how we use computers. But what people are saying is that it is amazing what we're seeing with ChatGPT and other large language models, but there is still they have very little capabilities to do things on our behalf outside of their environment. But now people are creating these tools that are going to connect these models to the rest of the internet, the rest of the services that we use, and they're going to be able to do complex tasks, tasks that has multiple steps, that require some planning, that require some decision making to execute the task. They're going to do that in our name. So, for example, instead of just asking to ChatGPT, okay, create trip, a trip plan for Ricardo's trip to Iceland. I can say, create the trip plan. And now that I like the trip plan, do all the reservations, put all that data in my calendar, notify people that I'm not going to be available during that specific time, and they're going to do everything for you. They're going to pay for the hotels. They're going to pay for the rides and things like that. So that's where the agent development is happening. So that can also, again, change how we use computers. So my big hint and recommendation for everybody is we need to start using that. We need to start experimenting with that, because it's a new technology. It's very accessible. It's really available. It costs close to zero, depending on what you're going to use. but there is a lot of learning that we need to develop on our side to understand how that technology is going to impact and how we're going to use that in our daily life. So there is a lot of learning and discoveries to be done from now on. But then when we start to use, especially if we start to use it not just for fun in a more professional way, you have to be aware that on the surface, it looks calm and very easy. I go there to ChatGPT, ask for something, it gives me a response that is really well written, and I think it's almost 100% correct. But then when you start to get close or building more sophisticated things, you have to do more than just use a chatbot, right? You're going to do API integrations with your existing systems. Once you integrate there, you see that, oh, well, the model is not answering exactly how I want. So start tweaking the prompt. You have to do what they're calling prompt engineering to make the model give you the answer you want. Sometimes you need to bring information from outside database. That's a technology that they're calling RAG. That's a retrieval augmented generation, which is you make a question for the model. The model understands the question. It queries an external database or source of content, brings the answer, process the answers, and then give you an answer based on that. So that's how you can connect, for example, your CRM system with AI. So if you ask to ChatGPT, which customer that I have that spent more money in my company last month, ChatGPT doesn't know. But if you connect that technology using RAG to your CRM, it can query the CRM and bring the data. So there's a lot of those things that we can do. But then the problems start to arise, right? You're going to suffer with an edge case, which are those particular cases that breaks the technology. You're going to have the hallucinations. They're going to respond with great confidence, something that is completely bananas. You know, it's not a proper answer for your problem, for your question. You're going to have latency issues because you have to query those models, and then you have networking issues. You have the time that the process needs to, the computer needs to process the query that you're doing. So a lot of problems start to emerge to create real, how can I say, production-ready applications of AI at a large scale. And then there are other kinds of problems that when you dig even deeper, you're going to see. For example, security issues. You're sending a lot of your private data to those models. How those models are handling that data. Trust and transparency. You don't know exactly how the model is making decisions. Sometimes it's very hard to explain what those neural networks are doing. So there's a lot of challenge ahead of us. And that be sure that there's a lot of very bright people trying to solve that, but it's far from being solved. So we're going to see a lot of development from here. Okay, so how do we surf that wave, right? So it's a few hints on how you should look to that. I think the first one is start using and try to learn from iterations and try to learn fast. I mean, focus on learning, developing the abilities, not just for yourself, but for the company that you are, for this new world. And when I talk about learning in iterations or learning in an iterative way, the most important thing is that you have to make the cycles of testing, getting a result, getting the result and try to understand that and using that to learn and improve. You have to make that in a very agile and very fast way. Otherwise, you're not gonna be able to cope with the speed that things are happening. So if you do very short iteration cycles, you can learn faster. That one is really important. You remember that on the previous slide, I mentioned how fast those things are evolving, how much things are being developed on that space. So when you're designing something that, for example, you're designing a product that uses AI, or you are adopting AI in a way that you're going to use in your company, you have to try to understand where the evolution of AI is going to lead the AI providers. Because if you create something that is going to be on their path of evolution, probably you're going to be a roadkill of AI, because they're going to grow and they're going to run over you. So the AI is going to grow, and you don't want them to grow on top of you. What you want is that the more it grows, the better you are. So for that, you need to make a clear line on until where is the innovation of AI, where is the role of AI, and where is your role, where is your innovation, where is your uniqueness on the things that you're building. So trying to have that in mind. So just to exemplify, let's say that you're creating a solution for AI to make ChatGPT works better with a specific set of data. Let's say that there are some categories of data that ChatGPT doesn't do well, and you're creating a lot of technology to make ChatGPT, the current version, to work well with that. Okay, that's a good thing. But the problem is OpenAI is trying to make ChatGPT better every day, is making ChatGPT to handle different type of data every day. If that type of data is something that probably they're going to do it, maybe ChatGPT 5 is going to do what you spend a lot of time building. And then your uniqueness, your differentiation is gone, because now everybody has that on the new version of the model. So you need to have these kinds of things in mind. And because of that, it's also important to understand that design is really, really important. How you solve the problem is important. That's something that a lot of entrepreneurs and people that are using new technology forget to think about it, is that you need to understand the problem you're trying to solve really well and try to design how the technology available is going to be used for that. Otherwise, you're going to see those very bad use cases where you're going to have crazy results because you haven't thought on that before. You didn't spend time understanding how the user was going to use that. For example, I saw recently in Brazil, one player created a chatbot to answer questions about his product. And when the user started to asking the chatbot who was the best product on that category, the chatbot was pointing to the competitor. So that's the type of thing that you don't want to happen, because you didn't previous thought on how people are going to use that. How do I really create value with this technology? So design is really, really important. I think the more we're going to see the technology being available for everyone, more importantly is going to be the role of people that design things around the technology. So that's a kind of my ending chapter on AI, and maybe just to open the view here a little bit. I think that AI is just one of the technologies that will transform the world from now on. That was part of what brought me back to Silicon Valley, was not just AI. I mean, AI is a big part of that, but there are a few other technologies that are being developing and maturing right now that together with AI, I believe we're going to see a tremendous change in everything. So let's just take a look on a few of them just for you to have in mind. So it's going to be very fun time from now on. Artificial intelligence in the core of everything, right? Data, machine learning, artificial intelligence, that's one big chunk of everything. But then if you imagine that artificial intelligence is all these in the information world, right, in the bits environment, we're going to have the equivalent of that in the physical world, in the atoms world, with robotics and IoT. So when you look to these Waymo self-driving car in the roads of San Francisco, that's a mix of robotics, the car is a robot, with AI being able to solve a problem, which is autonomous transportation. Energy is going to be super necessary for all that, right? One of the key concerns of a lot of people around how much development and effort we're putting on creating those large models, those very big data centers, is okay, this is what's going to be the impact of that in the environment, how much energy we're going to need for that. So there's a lot of breakthroughs actually happening in the energy space as well to support all these. A lot of things powered by all these around biotech. So multiomics, I mean, how we understand the different genomic maps that we have, not just your DNA, but the DNA of your bacteria and things like that. All of that is going to generate a lot of innovation and breakthrough. Public blockchain, I believe it's about time for it to happen. We're starting to see very good applications for blockchain. I'm not talking just about crypto, the currencies, but actual applications using the technology of blockchain. So, for example, the Central Bank of Brazil is now starting to test what they call DREX, which is a digital currency from the central bank in Brazil that is going to be an important piece of the financial sector infrastructure in Brazil for a lot of the applications, make it way more modern, more fast, more reliable, and more transparent. Extended reality, like augmented reality, virtual reality, those things are getting very, very close to be able for us to use on a daily basis. I still don't think that we're going to carry that very big headset that you use that for 10 minutes and you're going to have a headache. But now we're seeing smaller prototype that fits on your glasses and things like that. So I think we're getting close to the iPhone moment of that technology. Space exploration, it's happening. See what's happening with SpaceX and a few other companies, and quantum computing that could be the enabler of the next decades of evolution on that curve of compute power that I showed you before. So there are a lot of things are happening. And the interesting thing is that differently from previous new technologies that we saw in the past, for example, when we saw the emergence of the steam engine around the 1800 years, but then we had the railroads and telegraph before. Now we're seeing a lot of technologies happening at the same time, and the effects of that in our lives and the economy and everything is going to be compounded because one technology is going to catalyze the other. So we have to be ready to expect a big massive change from now on. So this is an interesting thing, and why I believe AI is so important on that. They try to create a matrix that shows a few of those disruptive technologies that I mentioned and see how each of them interacts with the other. So, for example, how cryptocurrency interacts with smart contracts. So it's a big interaction, right? Smart contracts and crypto, super connected one to the other. And then if you go further, you're going to see the technology that is more connected to everything in terms of how big is going to be the impact of that in accelerating the other technology is AI. So AI is going to work as a glue, as a catalyst for all these other technologies that we're seeing. So that is it. I would love to hear questions here. I try to put all these in an interesting way, but the conversation is going to be way funnier from now on.
Wow.
Oh, my friend, thank you very, very much. You know, look, it's brilliant what you said, Manuel. You can now come back. Yeah, it's absolutely brilliant. I'm seeing here the comments on the chat saying, look, it was super worth to spend this hour with you and this. So Manuel, thank you very much for your time, and just for you to be aware, so Manuel did this as an act of friendship, okay? So he did this to share with us his thinking, and for me, when I watched it the first time, it was so deep for me to understand what is coming and the numbers. So thank you very, very much on that. So for those who are watching, just stay tuned a little bit, because Antonio and I will want to share something with you at the very end. But I want just to share with you, Manuel, 4 questions here. So the first question from Ahmed is, does AI improve the quality of outcomes of a profession?
Oh, that's a great question, Ahmad. I think that AI is a tool, right? So every time we have a new tool, if you use a tool well, it can improve your outcome. It can improve maybe scale. It can save you time. It can allow you to do things that you were not able to do before. But it depends a lot on how good you're using that. So in the end, it is the tool is available for everyone. How to use the tool is what is going to make difference for everyone. So that's why I believe that starting to use is the key thing here, because then you're going to get used, you're going to try to understand the nuances, you're going to see what works in your use case and what not. But talking about my personal perspective here, since I saw these things a few years ago, I forced myself to try to use AI in everything I do. So if I'm writing a report, I'm using AI to help me to think about the report. I'm not using AI to write the report. I prefer to have my own voice there. But I use AI for research. I use AI to review the report. I use AI to review the English on the report. So that's one thing. I'm an avid note taker, so I like to take notes. I use a special tool to take notes. And I noted that a lot of the times there was a task that I like to do is, let's say that I'm taking note with a conversation I had with Antonio. I like to create a page on my note take software with Antonio profile so that I could reference to that later. And if Antonio is in a company, I like to have a small blurb, a small kind of a record about the company. And I was doing that manually. I was going on Antonio's web page, copying the URL, writing that myself. I say, hey, let's try to do that with AI. So I wrote a small plugin for my browser that when I click on Antonio's web page, I just click on that. It's going to go to the page, read the page, send that to GPT API, and ask for GPT to summarize what Antonio is, what are the data, and then put that in my note-taking thing. So I do that, now it's super fast, and my databases became more reliable and more interesting. So there are a lot of things that you can do. So I think the answer is yes, assuming you're using it in a proper way.
Great, thank you. So we have so many here. So does the training of these AI models consume energy in the same scale as blockchain? If so, this may be a big issue. Claudio asked this question.
Yes, the training of those AI models is tremendous in terms of how much compute power they take, and also compute power means basically that you need to use energy for that. So it's so important, the impact of energy in those models, that there are a lot of infrastructure companies now being created and being invested, that what they're doing is they're buying future, how can I say, they're buying energy in the future. So they're going to an energy provider, say, I want to secure this amount of megawatts hour for the next 10 years because I'm gonna need that to use on my data centers. And I know that if I don't buy and I don't secure that energy now, and somebody else does that, that's going to be a bottleneck for what I'm trying to improve. So the answer is yes, and that is a problem, because we have, of course, to make the energetic matrix to answer, right, for these new demands of energy. But the other side of that is that there is a lot of development happening in how to optimize the algorithms, how to create more efficient computers to use that. So it's kind of it's a race, right? You first increase the demand. Now that you increase the demand, now you try to optimize the use of energy. Maybe you're going to do that, and then you're going to increase the demand again, and you're going to optimize again. So it is a problem, but there are a lot of people working on that.
Thank you. Paul, I'm trying to learn AI and I got some coverage, but what would a learning tech stack timeline look like?
Okay. I put it in a few ways. I think the immediate thing to do is use AI tools, right? Use AI-powered tools, because that's going to help you to understand the capabilities and what the technology can do. So start using these LLMs, start using other tools that use AI so that you could see what AI can do, what AI can't do. So that's first step. I think second step is try to bring AI now into your own workflows. I mean, try to bring that to your real life. So just like what I was saying, I have this workflow of taking notes. How can I make AI now make part of the work for me? Of course, it required some knowledge in terms of programming, but there are a lot of ways today that you can use these no-code tools, low-code tools to create those automations. There is a lot of things that you can do today without proper technical knowledge. So that's another thing. And then if you want to go deeper, then you're going to have to start touching not just the how can I say, the consumer-ready products, but use the APIs, do fine-tuning of a model, create your own GPT. So there are other things that you can do that is going to go further on that. So for me, it's a continuous. Start using, then you're going to see limitations. You're going to try to bring that to your life in a way. You're going to find new limitations. You're going to go deeper, and that's for me, that's the process.
Yeah. Thank you. George asked, will the webinar posted on YouTube? Yes, and also it's already on LinkedIn and other platforms, okay? Also from George, having a currently used database that contains data, where do I find resources for data preparation? Is there a model or framework for data?
That's a great question. I mean, data is the, how can I say, the most necessary thing and maybe the most valuable thing in this AI world, right? Especially if you're not use somebody else's model, if you use that to your own things in a very unique way, you need to bring your data to the table. And one of the problems is that majority of the companies, they have very bad data architectures. Data is siloed in different systems. Data is not standardized. There's a lot of things there. So there are a lot of tools, big providers and actually small providers, trying to help people to do that, to facilitate, right, to create those infrastructure. But there is no magic rule here. You have to start to organize your data and make it available. At least you need to find a way to have all your data accessible in a good way that you could use in these new applications. And for that, you need to build your data lakes, data warehouse, organize your data. So you need to use the tools like the Databricks, the of the world to do that. So I don't have here like a clear path for that. I can send that to Ricardo, and I believe there are a few good references on the internet for that.
Thank you. Federico, what about AI evolution outside the United States? Lack of capital, competence?
Yeah, that's a great question. China is doing a big thing with AI, and it's not new. It's from a long time they have been doing that. I started with machine learning before, and now with generative AI. But more recently, because AI is such an important thing for the economy, and some people understand AI actually as a sovereign question for the US. There is a lot of investment happening here, and they're also trying to bring a lot of the brains and the talent to the US. So I think the key place for AI today is Silicon Valley by far, but there are other very good hubs like China, Israel. So those are places where you have the resources, the talent to that. Unfortunately, the talent is a hard thing, because how much money they can pay for this talent here, especially in these big competition across the big players full of money, it's hard to compete with those guys. But what I think that is going to happen is you're going to have, let's say, infrastructure. The question is really good, because help us to talk this thing now, which is you have to understand the AI thing as a stack. It's a stack of technology. So on the bottom of the stack, you have the infrastructure. You have the chips, the data centers, the computers, everything. So that's something that I believe is going to be a development for big companies. People are saying that there are data centers that are going to cost on the order of $100 billion, one data center, $100 billion, one data center for AI. So people are building such big data center. And that's going to be something for maybe a handful of companies in the planet to build those data centers. And those are the big guys, you know the names. On top of that, you have the foundational models. That's what OpenAI, what Google, what Cohere, what Anthropic are building. That's also super expensive, because you need to buy a lot of compute capability. You need to buy a lot of energy. You need to ingest a lot of data. You need to have a lot of talent. So those are also, is going to be a few companies. Then you go to a next level. It's going to be tools, right? Tools to facilitate people to use AI. And then you're going to have the application. So what I think is going to happen is infrastructure, foundational models, and the important part of tools, that's going to happen in well-developed markets like Silicon Valley, China, and maybe in Israel. But on the rest of the markets, what we're going to see a lot is the development of applications and tooling. So that's where I believe, for example, Brazil is going to have a lot of things, because that's the things that are closer to the problem that needs to be solved. So I believe that we're going to see in these other markets focus on applications and not necessarily on the infrastructure.
Yeah, thank you. Let me just skip here to Michael. Manuel, I'm also convinced that the great usefulness of AI, of what AI can do. But here is my kind of philosophical question. Do you think AI model can really understand things? What about conscience in the machine? This is Jeffrey Hinton all the time.
I'm going to say I'm not well prepared to answer that. That's such a profound question. But there are interesting discussions around that, right? What exactly is conscience? There is a lot of people questioning what is our understanding of conscience, and what exactly is thinking, because a lot of what those models are doing, some of them are really inspired in how we think ourselves, not exactly the same thing, but there is a lot of inspiration in these bio-inspired models. And what we're seeing is, if you go to if you look to that in a very cold way, there is actually no thinking or reasoning happening there. It's basically an algorithm trying to predict what is the best answer for a prompt, right? There is a way that it does that. But on the other hand, that are people saying, okay, but you can make those algorithms take decisions, plan for things, and that's more cognitive type of tasks. So I don't have a good answer for that. What I try to look is, does it, besides of a philosophical and how that's going to impact what we perceive, we humans, as our uniqueness, right? It is oh, we are very cognitive beings, we're conscient and things like that. I don't know how exactly that is going to impact us, but if it's solving the problem in a good way, why does that matter? You know, so that's so there's another way to look to the problem, but I think we're going to learn a lot about ourselves now because of the development of AI, because we're going to have to face those questions all the time. So it's I don't think we have reached that point yet. There's a lot to happen here. Yeah.
Yeah. Thank you. Great discussion. One thing, Richard, how do you think project managers can effectively communicate the benefits of AI to stakeholders who may be resistant to change or unfamiliar with the technology?
Oh, maybe that's a question for Ricardo and Antonio, but what I'll say is more generic. It's not just a project manager, right? That's something that I'm telling all my entrepreneurs, the companies that I invested, the people that I mentor, which is, guys, there is a tremendous tool available on the shelf, and that tool can make your life easier. That tool can make your tasks faster. That tool can make your reach go further. Why you're not looking to that tool? So that's for me, that's the fundamental thing here, which is it's like saying, okay, there is this new communication method. I'm not gonna use the new communication method. For me, it's a very short sight type of view. So what I'll try to do is to maybe the best way to convince people, so that's another way to look to the question, which is bring examples to the table. And the examples can be not necessarily in something that is let's say if you take project management, right? There are many tasks within project management. If you can make an example that the guy can easily see, oh, this way these people use AI to solve that problem, I can use in this particular task in my project management set of tasks here. I think people very fast, they're going to see that there is an advantage in using that, and then they can start testing and adopting and things like that.
Great. Loredana, how can we ensure the responses from AI are not leading to unethical results?
That's a great question. Right now, it's very hard to do that because we're also learning that those models, they have a lot of biases not coded, but that emerged from the way they were coded and trained. So there are biases on the models itself. So one way that people are leading with that, and not just biases, you have a few kind of problems. You have the biases, you have the hallucinations, which is the model answering something that it's not true, that didn't exist. What people are doing is creating what they call guardrails around an AI application. So let's say, for example, that you are using an AI application to answer a support request from your company, right? You're gonna train a model based on the historical database of all the interactions your human customer support representatives had with your customers, because then you're going to have the knowledge on how to solve the problem there. You're going to send the question to the model. The model is going to answer, and you're not going to give the answer right away to the user because, okay, let's check if this answer is good enough. Let's check if this answer is not doing something that I do not want. And the interesting thing here is how you check that in an automated way. People are using another AI to test the answer of the first AI. So, for example, you can bring out one model that is more sophisticated, bring the answer, and then you have another model that is a restricted model that you trust that model really well. And the unique thing that model is going to say is this answer okay? For example, is this answer not being not generating discrimination? Is this answer not offending the user? Is this answer not how can I say, leaking important proprietary data here. So people are creating those right rails and the tools to make that. And once they discover that, okay, here the answer of the model had this type of answer that I didn't want to do, they use that as a feedback to the system to train it and say, hey, this is not acceptable. I don't want to see that type of answer in the next time. So they're using these feedback loops to improve the system on our own. So that's a very good question, because if you look to applications like healthcare, financial sector, one of the things that are actually slowing down the deployment of very large-scale AI-based solutions to the general public is actually the fear that these type of things can happen. So people are still creating the confidence, the necessary confidence to roll out that to the system. You don't want to see a model taking your user to a bad place, you know?
Yeah. Manuel, just our last question. What is your thinking about artificially generated data, synthetic data being used to train AI?
That's really interesting. One of the bottlenecks for continuously evolve the models and the algorithms is actually data. And one of the ways that you can solve that is actually generating synthetic data. So it's basically use another algorithm or another model to generate training data that we're going to use to train your model or to test your assistant. I like the idea. I think for a lot of applications that's super useful, but you have to be careful with how good is the synthetic data that you're training, because if you're not aware that synthetic data that you're generating already has biases, then those biases are going to be learned by the model, and then you're going to enter in a situation that you're enhancing the bias and the problems that you have. So you're going to have a side effect of the synthetic data. And there are already some research showing that in some cases that really happens, but in other cases it doesn't. So let's give you an example. Let's say that you're training a system to learn how to execute a financial transaction from instructions from the user, right? You can generate a lot of how can I say, synthetic data for training for that, because that's a very controlled set of information. You know that you can extrapolate a lot from how users are gonna ask for the model to do a specific transaction. Then you can use that in a way to train the model if you don't have the data, because it's a limited type of thing. But now let's say that you're generating synthetic data to train a drug discovery model. That's a super complex thing. You need to generate data on top of that represents how real organisms are going to respond to that. If you misgenerate the data here, you can have crazy results on what you're training. So you need to be aware of those things.
My friend, look, thank you very much. I have no words. You know, we still have something like 12 questions, but we'll try to record them. Just before we move to the closing, I just want to share one thing with you. You know, instead of, we want just to do the opposite. Instead of charging for events on the IPM day, like we saw, we did this, and Antonio and I this morning, we decided also to, for those who are interested, to give you know, a voucher for those who want to join us on the masterclass. Okay, this is for the masterclass. You can use the code up to next week, IPM day 24 for 100 for the masterclass. The last one in December, it's already confirmed. And for the certification that it's really skyrocketing, okay, the certification. So we also are creating a coupon, IPM Day 24, for those who are interested. So it's a great opportunity for you, and also a way of thanking for joining us on this initiative. Look, Manuel, I have no words to thank you, okay? I know your time is so precious, and you spend this time with us. So thank you, Antonio. Ball to you now.
Thank you, Manuel. I think you have a gift that very few people have, to explain simple things that are complex. So I think that's what makes you special. And I've seen a lot of AI presentations, and yours by far the top ones, because
thanks.
I understand and I can connect, and I can I'm eager to reach and learn more. So thank you for your time. Thank you for joining us today. Thank you, Ricardo, also for organizing, and thank you, everyone.
When I finish this type of section, it brings me joy, and something that it's so amazing to help people to learn, and to become better. And this is really, I feel really, blessed when I see a presentation like this one. So thank you very much, Manuel. Antonio, thank you, my friend.
Thank you.
Safe travels tomorrow.
Thank you.
Goodbye to everyone directly from Iceland, San Francisco, Madrid, and very happy PM Day. Okay. Thank you, Manuel. Thank you, Antonio. Bye.